Hey guys, it's Friday, it's April 29th, and I'm homesick, which confuses me because I haven't had a fever, which is why I didn't go to the doctor on Wednesday when I started feeling the sore throat and the tenderness here in the lymph nodes. Because when you have a fever, you're sick. When you're sick, you have a fever. It's like a biconditional. And we now have a counter example of a case of being sick and not having a fever, and this confuses me and upsets me greatly. And I know you care. The reason I'm putting this together, though, is to kind of make up for some of the things that you might not have picked up in the book or in the worksheets I left, and to go through some of the big ideas that you should be able to get on more or less without lots of class time spent on it. So here's some basic definitions for chapter 11 we're going to be using. A chord is a segment. So you've got your circle, and it's going to, let's get my highlighter going here. Chord, there we go, right there. It's a segment with a point on the 2 points on the circle. Now a secant is a line that includes a chord. So here's L, which is a secant line. Now you can see there's a chord right there. That is the length, it runs along inside the circle and the interior of it. But because it's a line and it continues, it's called a secant line. Now I could, if I wanted to extend AB into line AB, it would go from being a chord, a segment, to being a secant line. Let's see now so recap. Chords are segments, secants are lines. Now there are two kinds of lines. There's a secant line, and it goes through twice. So it hits here and it hits here. Now a tangent line only hits once and then goes off on its own. Now when we talk in language, we talk about going off on a tangent. So we're talking about some topic. So perhaps we're talking about what people get paid for what they do for a living. And then we go off on this tangent of, are lawyers overpaid? And then we get into what lawyers do, not what they get paid, but we've gone off on this tangent. And that's where the phrase comes from. To go off on a tangent means to go off on this tangent line. Now the point of tangency is the actual point where it is. So if you think of it this way, you have your circle. If the line goes through the circle, it's a secant. If it's touching the circle, it's a tangent. And if it's not touching at all, it's just a line in a circle. Nothing interesting. Now, we can also talk about types of circles. Now, there are congruent circles. These are circles that have the same radii. Remember, a circle only has one measurement, and that's its radius. So to establish that two circles are congruent, or the same in size, they just have to have that same radius, that one same measure. Concentric circles are circles with the same center. Now, there's an easy way to picture these. You take a drop of water into a pond and it makes concentric circles, because the center of all of those expanding circles is where the drop of water hits. And as it drifts out, that's the concentric circles. Now, tangent circles, they're a little trickier to get your head around at first. Think about that point of tangency, where perhaps I have a line. So here's my line. It's a very bad line, but there's a line there. And so I've got the tangent line. The two circles share that tangent line. A way to think of this is to think about gears. Okay? Okay, not those gears. Those gears. Now, you can see there's a point of tangency where the two gears touch at exactly one place. That makes them tangent circles. Now you can also have, these circles are, what's the technical term? Externally tangent circles. That makes sense, right? They're outside each other. We can also do internally tangent circles. So here's one circle, it goes around the big outside, and here's another circle, it goes around on the inside, and then there's the point of tangency right there, where the two circles hit. Now when we talk about lines, there's, in this idea here, there are a couple. There's the idea of a common tangent. So common tangent. So start with that idea. Common tangent means that the two circles both have a tangent line in common. There's a line that connects them. Now I can move these circles around and those tangent lines will still be there. You can always draw a line that connects those two dots. Now external tangent means that the line is on the outside. Think you want to be looking at this region right here. Does that tangent line go through the region between them? So if you think of like the Earth and the Moon, and this is the space right here in between them. An external tangent doesn't go through that space. Contrast that to an internal tangent. The internal tangent kind of cuts right down through there. Now, you could also, if I look at just this one tangent line, let's just look at P. Ignore Q for now. You can see that A is below it and A is on top, B is on top of it. So they're on opposite sides of the tangent line. Whereas if they were external tangents, they're both underneath it or they're both on top of it. They're both on the same side of that tangent line. So that's another way of thinking about this. Now again, think about this region between the Earth and the Moon. And so now this tangent line coming off A is then going into B. Now these theorems basically boil down to one core definition. And that is that tangent lines are perpendicular to the radius. Excuse me. There's really not much else going on here. If it's a tangent line, it's perpendicular to the radius. If it's a radius, it's perpendicular to the tangent line at the point where they hit. Rather than thinking of this as a theorem that you're going to have to prove, think of it as a rule to memorize. Tangent lines and radii make right angles. Just kind of file that away in there as something that pops to your head, so that when you see a picture that says, here's a tangent, you immediately think, I know that that means that the radius hits at a right angle. Now the other definition, now this one comes up in the worksheets, has to do with the idea that if I've got my circle and a point out here, which I think it's this way because I think I'm backwards on the camera, that these tangent lines are going to be the same measurement. So here's some external point, and here happen to be where it hits tangent. Now remember, tangent means that it's going to make a perpendicular line to the radius. If that's the case, then these segments are the same. There's only so many places I can put this. Now, from A going out to a point on circle P, there's only so many ways I can line that up so that it is tangent, it hits at a right angle. Because of that, it forces AB to be congruent to AC. And that's the way it works. And it has to do with the fact, really, that this, let me get a pen going here to help show this a little better. There's a radius right here and a radius right here. And those are going to be at right angles, and radii are going to be equal. And it's because of that property that I've now created a kite, and that forces these segments to be congruent. Where you're going to see that is on the second half of the reteach worksheet in the bottom part of practice A, where it has problems like this. RS and RT are tangent to Q. We want to find the length of RS, or the length of RT, because they're congruent. Because they're congruent, we can start right off by saying, hey, they equal each other. The property is, if we're looking at tangents, right? You with me there? And there's that common point R. Rule says these two segments are congruent, so we set them equal to each other. We do a little algebra, so we add 1 to each side and subtract n from each side, because this n is equal to 4. And then I can plug that back into either of the two expressions. Again, RS is equal to 7. That's really all you have to do with that. Now, there may be some on practice B, which we'll get as part of Monday's work, where they might throw a quadratic in here just to keep you fresh on your algebra skills. But I won't worry too much about that. The ones that you do have to worry about, though, are the ones that are, like this. You set them equal to each other and then do the algebra. Now, there is one problem on practice A that talks about a bike that's throwing some water off, and it has a little triangle drawn. Now, that problem specifically is meant to go back to this rule. So, oops, let's go back to where I want to be here. So that if I were to say draw this line here, so there's that line. If you know this distance, let's say it's 10, and you know that's a right angle there, and you know this distance, let's say it's 12. I remember I'm drawing with a mouse here. So that's 12. Can you tell me that length there? And I kind of hope you can, because when I'm looking at that, what I'm seeing is not a circle and a tangent and everything else. I'm seeing a right triangle right here. It means I'm looking at a Pythagorean theorem problem. I know you guys can do that. Stay safe. Have a good weekend. I'm going to curl up with some more tea, and I think I'm going to take a nap here.